So good evening all. Welcome to Sakal Vidya YouTube channel. Okay, still joining? Yes, okay. Tirupati, subscribe first of all. Subscribe. Like, subscribe and share. Okay, fine. Swati Singh, Balu, Avinash, Kirtana, Bhumika, Sankaranarayana, Ishwar, Gollapelli, Swati Singh, Bhumika, Saujanya, Pavan, Santosh Veera. Okay, Vital Kottapelli, Dasari Bharat, Venkat Alwala, Venkat Alwala. Right. Theory of equations. Okay, definitely. Because Malot Chandulal, Abhi creations. Okay, first year syllabus. Already completed first year syllabus. Harshita Ashok. Ishwar Rao, Chittala. Fine. Chimala Ganesh. Probability. Next after combinations, we followed by the probability. Bhumika. Okay. Revati. So mathematical reasoning is actually meant for JEE mains. So that will be discussed later. Definitely. That's very easy chapter. That is very easy chapter. Mathematical reasoning. Okay, Suchitra. Okay, Mahalakshmi. Good evening. John Blessing. Uppala. Sai Teja. Start physics. Okay. Fine, Kottapelli. Vittal Kottapelli. Hello. Prasad Dande. Malot Chandulal. Okay, let us wait. Actually, our scheduled time is 4:30. 4:30. Prasanna Hani, after a long time, where had you been? Why you are excited? What happened to you? First subscribe. Chirangi. Supriya. Sripriya. Okay. Vikar Ahmad. You expected which state? I am from Govind. Kartik. Bhumika. Bhumi. Salam alaikum. Good evening. Stay home, stay safe, sir. Okay. Thank you. Exactly. It's okay. Fine, Vikar Ahmad. Fine, I am fine. What about you? Shailada. Krishnaya. So new viewers need to subscribe, like, subscribe and share. Good evening, Ishwar. Good evening. So I know 4 or 5 languages. I know 4 or 5 languages. But I could understand some other South Indian languages also. Who is that Babai? Who is that Babai? Okay. Next chapter is Dheeraj. Who is Mr. Lokesh? I don't know about you. Who are you? So definitely I will explain the multiples and submultiples also, but I already completed. But moreover, so in the special sessions definitely I will discuss multiple and submultiple also. I already told you Lavanya, Edida, Satvik, Sri Devi, Saujanya. Where are you from, Sri Devi? So that will be conducted. Okay, let us start. Thank you. Okay, now yesterday we have completed some more concepts based on complex numbers. Today we discuss very important concepts. Today we are going to discuss. Okay, right. That means square root of a complex number z is equal to a plus ib or a plus or minus ib. So today we discuss first of all how to find out square root of a complex number. This is very important. Square root of a complex number. So square root of a complex number z is equal to a plus ib. For this one we need to follow the step. First step number 1, find mod z. Mod z means mod of a plus or minus ib whose value equal to root of a square plus b square. Am I correct? This is step 1. Now step 2. Step 2 is let us consider square root of z is equal to plus or minus x plus or minus iy. For example, plus is there, you get plus, minus is there, you get minus. Step 3. In step 3, we have x value. X equals to root of mod z plus a upon 2 and y is equal to, very simple, root of mod z minus a by 2. So after finding x and y, substitute here, we get the square root of z. So let us do some problems now. Okay, let us do examples. Are you ready? First question, the square root of 3 plus 4i. Square root of 3 plus 4i. The square root of 3 plus 4i means, first how to find out means, let us say this is z. First find mod z, mod of 3 plus 4i. This is equal to root of modulus of a complex number. Yesterday we have discussed 3 square plus 4 square. This is root of 9 plus 16, root 25 is 5. We know the mod. So now here we need real part, a value. A value is equal to 3. So now let us find out x. X is equal to square root of mod z plus a upon 2. That means 5 plus 3, 8 upon 2. Square root. Square root of 4 is 2. Y value. Y value is equal to root of mod z minus a upon 2. 5 minus 3, 2 by 2. Root 1, 1. So therefore, square root of 3 plus 4i is equal to plus or minus x plus iy. This is equal to plus or minus x stands for 2, y stands for 1. So 2 plus or minus I. Sorry, here 2 plus I. This is the answer. Okay, right? So now I will give one more question. Second question. The square root of 3 minus 4i. 3 minus 4i is square root of 3 minus 4i. Anybody? What is the answer? Square root of 3 minus 4i. So this also, the solution you need to do like this. First find mod z, mod of 3 minus 4i equal to root of 3 square plus minus 4 square. This is 9 plus 16, whose value is root 25 equals to 5. Here also real part, a is equal to 3, x is equal to root of mod z plus a by 2. That is 5 plus 3, 8 by 2, root 4 equal to 2. Now y equals to root of mod z minus a upon 2. 5 minus 3, 2, 2 by 2, 1, root 1 is 1. Therefore, square root of 3 minus 4i equals to plus or minus x minus iy, because minus is there. So this equal to plus or minus 2 minus I. This answer. Yes, Deepti. Sacha Arun Kumar. Right. Okay, now I give one question, all of you give your answers now. The square root of 5 plus 12i is 5 plus 12i. Okay, square root of 5 plus 12i. Anybody? What is the answer? Square root of 5 plus 12i. Right. Yes, correct, Upala Saiteja. Next step. What is the next step? Okay, Prasanna Hani. Right. 13, right, Venkata, Alvala. Okay, first let us say this is Z. Find mod Z, the modulus of 5 plus 12i. This is root of pi square 25 plus 144 is root 169. Square root of 169 is 13. So here a value is 5. So first let us find out x. X equal to mod z plus a upon 2. So 13 plus 5 is 18. 18 by 2 is 9. Root 9, 3. So now y equals to root of mod z minus a by 2. 13 minus 5 is 8. 8 by 2, 4. Root 4. Root 4 is 2. Therefore, square root of 5 plus 12i equals to plus or minus x plus iy. This equals to plus or minus 3 plus 2i. This is the answer. All of you check your options now. Everybody followed? No problem? All of you got it? Plus or minus, right. Plus or minus 3 plus 2i. Now fourth one. Square root of the square root of 7 minus 24i is. So if you practice all these questions with without paper pen also you can calculate it. Answers. Okay, 9 minus 4i. Deepak Puram. You try these questions. I will give 2 minutes time. Okay, Sumant, Shankar Narayana. Right. Balu, Suma. See the solution now. All of you check your solutions. Mod z is mod of 7 minus 24i. This is root of 7 square plus minus 24 square. 7 square is 49. 24 square is 576. This will be root 625. This is 25. Right, let us find out now. Here real part of z is 7. A is 7. X equals to root of mod z plus a upon 2. Here 25 plus 7, 32. 32 by 2 is 16. Root 16 is 4. Y equals to root of mod z minus a upon 2. 25 minus 7. 25 minus 7 is 18. 18 by 2 is 9. Root 9 is 3. So therefore, square root of 7 minus 24i equals to plus or minus x minus iy. So that equal to plus or minus x stands for 4 minus 3i. This is the answer. Right. I hope everybody will get it now. Right. Okay, now so next, fifth question. The square root of don't get confusion, minus 5 plus 12i is You can do it. Don't worry. You can do it. You can do it. Square root of minus 5 plus 12i. Square root of minus 5 plus 12i. Okay. Now the solution follows. Mod z, let us find out. Mod of minus 5 plus 12i, which equal to minus 5 square plus 12 square, root over. This is 25 plus 144, root 169. Root 169 equals to 13. So now here interesting factor. What is the interesting factor? Means a is minus 5, not plus 5. So now x becomes, x is mod z plus a by 2. That means 13 plus minus 5. 13 minus 5 is 8. 8 upon 2, 4. Root 4 is equal to 2. Now y equals to root of mod z minus a upon 2. 13 minus of minus, 13 plus 5, 18. 18 by 2 is 9. Root 9 is 3. That's all. Therefore, square root of minus 5 plus 12i. This is very important. This plus sign. So plus or minus x plus iy only, not minus. This equal to plus or minus x means 2, y means 3. 2 plus 3i. This is the answer. Deepak Puram, absolutely correct. What about Ishwar? Where are you? Are you there? Right. Prasanna, Sudhiru. Right. Shall I give one more problem? You try yourself. Sixth one. The square root of minus 7 minus 24i is the square root of Leelavati. Square root of minus 7 minus 24i. So this is odd questions only. I made it easy. Otherwise, if you want to do this, is actually 7 marks problem in IPE. But we are doing very easy manner. That's why it seems to be rather easy questions. It's not easy question. Okay, Sankanarana, wait. Go back and come. You will be getting. Here everything is okay. Network is good. Right now, solution. Find mod z, mod of minus 7 minus 24i equal to minus 7 square minus 24 square. Root. This is 49 plus 576, whose value is root 625 equals to 25. Okay, now we can find out x value. What is x value? Root of mod z plus a upon 2. Here a is this one, minus 7. 25 minus 7 is actually 18. 18 by 2 is 9. 3. Now y equals to mod z minus a upon 2. 25 plus 7, 32 by 2, 16. Root 16. Root 16 is 4. Therefore, square root of minus 7 minus 24i equals to plus or minus x minus iy. Because imaginary part contains minus sign. Here also imaginary part should contain minus sign. So plus or minus 3 minus 4i. So in this way, we can find out the square roots. Okay, now one more concept we shall discuss concept. Let z is equal to a plus ib, and next we know z bar is equal to a minus ib. Okay, so now first important point, root of a plus ib plus root of a minus ib is equal to how much? How to find out? It's very simple. 2 times root of 2 times mod z plus a, that's all. 2 times root of mod z plus a is root a plus square root of a plus ib plus square root of a minus ib, that's all. Only mod z we need to find out. This is z is equal to a plus ib, then substitute the value, directly we'll get the answer. Second shortcut, square root of a plus ib minus square root of a minus ib is there. You get imaginary part, I times root of 2 times mod z minus a. So this note down, this shortcut note down all of you. This is very important shortcut, directly we can do. So let me solve one problem, one example. The value of square root of 3 plus 4i plus square root of 3 minus 4i equals to square root of 3 plus 4i plus square root of 3 minus 4i. You will get real part you will get it. So that means you see the solution. Let us say z is equal to 3 plus 4i. Find mod z. Mod z is equal to root of 3 square plus 4 square. This is 25. We will be getting 5. Here a equals to 3. Therefore, required value, given expression is equal to square root of 2 times mod z. Mod z is how much? 5. 5 plus 3. That will be square root of 16. Answer is 4. Answer is 4. Root 13. No, 2 times. See, this is the bracket. Two times. Once again, all of you check your options. All of you understood now? Okay, Ishwar Golapelli, wonderful, very good. Balu, wonderful. Sudha, Krishnaya, wonderful, everybody wonderful. So one more example. The value of square root of 3 plus 4i minus square root of 3 minus 4i. Square root of 3 plus 4i minus square root of 3 minus 4i. Here in this case you get imaginary value. In this case you will get gunny fighter. Okay. In this case you will get imaginary value. Solution. Let z is equal to, you take this one, z is equal to 3 plus 4i. So I'll write directly mod z is equal to 5, no problem, a is equal to 3. Say this is given expression value. Given expression is equal to I times root of 2 times mod z minus a. I times root of 2 times 5 minus 3, 2. I times root 4, that is 2i. 2i. Wonderful. Wonderful. Very good performance, all of you from. Okay, I will give one question. Now you need to give the answer. The value of root of 7 plus 24i plus root of 7 minus 24i. Now try this question, all of you. Try this question. RVR. Thank you, Nana, thank you. Okay. Right. Okay, I will do it now. Perigu Ramya, 6i. Right, I will check now. Okay, solution. So mod z is equal to mod of 7 plus 24i is root of 49 plus 576 is root 625 is 25. Here a equals to 7. Therefore given expression value is what? Square root of 2 times mod z plus a. Square root of 2 times mod z is 25 plus 7, 32. Square root of 64 is 8. 8 is the right answer. 8 is the right answer. Okay, I will give one more question, last question on square roots. Definitely everybody will understand the square roots. Now you will not lose a single mark if this question is given in the examination. Fourth one. The value of square root of 5 plus 12i minus square root of 5 minus 12i is equal to, yes, root 64. The value of square root of 5 plus 12i minus square root of 5 minus 12i. Whenever minus is there, you will get imaginary number, I times. Okay, let us see. Very good. Very good. Right. Very good. Solution mod z is mod of 5 plus 12i. 5 square plus 12 square. It's nothing but Pythagorean triplets. Don't worry. 5 12 means 13 you will get. 25 plus 144 is 169. Square root of 169 is 13. Right. Here a equals to 5. Therefore the given expression value is I times root of 2 times mod z minus a. I times root of 2 times mod z is 13 minus 5 is I root of 16, so that we get 4i. So wonderful performance, everybody. Right. Now I give one question. You try yourself. fifth one. The value of root I plus root of minus I equals to the value of root I plus square root of minus I. Okay, this is just like a namaste. You are testing whether I know Telugu or not. I think so. Right. Root I plus root of minus I. Okay, let us solution. You see, mod z is equal to mod I. Mod I means imaginary part, real part 0. So root 1 you get 1. A is 0. Real part is 0 here. Therefore you get now given expression is equal to root of 2 times mod z minus a. That is root of z into 1 root 2. Okay. Similarly you remember this one also. This will be useful in the examination. Square root of I minus square root of minus I equal to root 2i. Root 2i. Root 2i. So this remember. Important. Okay, enough now. Actually more than enough. The square roots now you might have practiced it well, so that any problem now you can solve. You are able to solve it. Okay. Now, so let us discuss. We talk about cube roots of unity now. Let us discuss cube roots of unity. Cube roots of unity. Cube roots of unity. This is very important concept in this complex number chapter. Cube roots of unity. This is very important concept. Cube roots of unity. What is meant by cube root of unity? For example, the solution of x cube is equal to 1 is called cube roots of unity. Cube roots of unity. Unity means 1. That is, x is equal to, we can write 1 to the power of 1 by 3 or cube root of 1. So now this cube root of 1 are given by 1 omega square. 3 values, 1 omega square, where omega is equal to minus 1 plus root 3i by 2. Omega square equals to minus 1 minus root 3i by 2. So you remember hereafter 1 omega square or okay, Ishwar, definitely after this I shall discuss Euler formula itself only. Euler formula this only. So now next properties of cube roots of unity. Cube roots of unity. Properties. So first property. What is the first property means? 1 plus omega square is equal to 0. First property. Second property is omega cube is equal to 1. Next, third property, 1 omega square are in geometric progression. Next, fourth one, 1 omega square are the vertices of an equilateral triangle. So these are the important points you need to remember regarding to the cube roots of a complex number. Yes, the value of omega to the power of 0 is 1 only. Okay. So now let us discuss this concept is important. How to find omega to the power of n, where n belongs to n. So let us discuss how to find omega to the power of n. Omega to the power of n. Here see, you find these steps. First step, divide n by 3. Divide n by 3. Step 2, let r be the remainder thus obtained. For example, if you divide n by 3, remainder is r, say r, where r value is 0, 1, 2, you won't get 3. So next step 3 is this omega to the power of n is equivalent to omega to the power of r. That's why here only I will discuss the value. I don't go for the lengthy discussion because I need to complete even Euler's formula also in this session. So that's why some examples I will discuss here itself only. For example, if you want to find out omega to the power of some 25. Now just divide this 25, 3 8 are 24, 1. What is the remainder? 1. So this is equal to omega to the power of 1 omega. For example, if you want to find out omega to the power of something 36, this 36 is the divisible by 3. So omega to the power of 0 is 1. Now similarly you can find out omega to the power of 20 also. Any number you can find out, no problem. Omega to the power of 20. Similarly you can say that omega to the power of 3n, multiple of n, is always 1. So 20. If 20 is divided by 3, 3 6 ja 18, 22, 3 7 ja 21, 1, 3 3 ja 9. So 1, remainder is 1. This equal to omega to the power of 1 omega. Understood now? Okay. Now I ask you one question. All of you do it now. How many of can you do? I'll check one example. If 1 omega square are the cube roots of unity means 1, then 2 multiplied by 2 to the power of omega into 2 to the power of omega square equals to first option 2, second option 1, third option 3, fourth option -1. Okay, so you complete this problem. This was the previous question. That is actually, this question is given 2012 Ecet examination. 2012 Ecet examination. This question was given. But sometimes this kind of questions may be given for Eamcet also. Okay, let us do it now. Since bases are equal, the powers are added. This can be written 2 to the power of 1 plus omega square. Since we know that 1 plus omega square equals to how much? Is 0. So this will be 2 to the power of 0 is 1. So second option is the correct option. Option 2. Second option is the right option. Understood now? And also one more question I will give it. This type of question may be asked in the examination also. This is the previous question of Eamcet as well as Ecet both. Okay, 1 det of 1 omega square omega square 1 here omega square 1 omega equal to first option 0, second option 1, third option -1, fourth option 2. So the determinant of this one we need to find out. The same question. This is also the previous Eamcet and Ecet both. Ecet and Eamcet. Okay. Third solution, det of 1 omega square omega square 1 omega square 1 omega. Here apply. Yes, it's IPE problem only, but it may be given. R1 is written as R1 plus R2 plus R3. So we get now 1 plus omega square. This also 1 plus omega square. This also 1 plus omega square. This is omega square 1 omega square 1 omega. See, this is 0 0 0. So that means 0 0 0 0 something. If all elements of all the row is 0, then that will be obviously 0. Answer is 0. First option is the right option. First option is the right option. Yes, by matrices, it's not a matrices problem actually. So this application of the determinant of the matrices in complex numbers. What we say that connection problem. This is called a connection problem. Right now. Right. Next concept. Let me discuss now. Next concept. So now, yes, I shall switch over to the next concept. So graphical representation of a complex number. Z is equal to A plus IB. So that means, can we represent any complex number graphically? That can be represented. Yes, why not? We can represent it, but that plane is called in different plane. So that means we need to take like this. So x-axis and y-axis, this is x-axis, x dash, this is y-axis and y dash, this is origin. So now this is represented by a point in this plane. So for example, this is denoted by P point A comma B, where A is the real part, B is the imaginary part. That's why this is called real axis. This is called imaginary axis. Imaginary axis. Imaginary axis. So the distance from O to P is nothing but mod z. Mod z. Mod z is the distance from 0, 0 to the point A, B. So now let me come to the here. Drop the perpendicular P onto the x-axis, say PM. The angle subtended by OP with x-axis, say theta. This angle is theta. As for the figure, this will be A, this will be B. Now write down, generally say this is R. For example, let us say R. R is equal to root of A square plus B square, only say R. Now we have from triangle OPM, define cos theta. What is cos theta? Cos theta is equal to adjacent side by hypotenuse, A by R. That A equals to R cos theta, we get it. Now define sin theta. Sin theta is equal to what? Opposite side by hypotenuse. Am I correct now? That is B by R. So now this B is called R sin theta. Here, very important thing you need to remember, here R is nothing but mod z, whose value is root of A square plus B square, where theta is called amplitude. Amplitude is very important word. Amplitude or argument. Amplitude or argument, we can say that. Amplitude or argument. Now this plane is called specially organ plane. Organ plane. It's not coordinate plane, organ plane. Or we can say Gaussian plane. Gaussian plane. Complex numbers are denoted in the organ plane or Gaussian plane itself only. Theta is called amplitude or argument. So now let me come to the, so for example now here, as we have Z is equal to A plus IB, since A equals to R cos theta, B is equal to R sin theta. Let us substitute these two values in this A plus IB. We get like this, R cos theta plus IR sin theta. Let us take out R common. If you take R common, you get cos theta plus I sin theta. So now this form is called trigonometric form, polar form, or mod amplitude form. That means any complex number can be represented trigonometric form, polar form, mod amplitude. Three names are same. Generally we say that mod amplitude form, and moreover you remember now this cos theta plus I sin theta can be written as cis theta, short form we can write it, or this cos theta plus I sin theta can be written as e power I theta. This is called Euler form. This form is called Euler, the great mathematician Euler form or Euler's form. Understood now? Cos theta plus sin theta. So therefore now the Z can be expressed both ways. R cos theta plus I sin theta or we can write r cis theta or e power I theta. This is very, very important notation. So all of you might have understood now. Okay, got an idea what is meant by how do we get actually this all these forms, trigonometric form or mod amplitude form or Euler's form. That is the Gauss theorem. Gauss theorem is different. That is Gauss theorem actually you have in physics. So that is a different flux. Whenever it's come to the flux in the electricity, you have the Gauss theorem. Or in complex analysis also we have the Gauss theorem. Right, e power I theta. Right, all of you understood now this concept now? Okay. So now this point, how to write instead of better write express. That's a good word. How to express z is equal to a plus ib in mod amplitude form. This is very important. Mod amplitude form. Mod amplitude form. If you are able to express in mod amplitude form, it is very easy to, yes, Gauss theorem in physics. It is easy to express in Euler form also. Yes. So I did MSc physics also. Right. So now the solution, sorry, not solution, process, algorithm. Step 1. First find modulus. R is equal to mod z is mod of a plus ib. This is root of a square plus b square. First and foremost thing, to express in mod amplitude form or trigonometric form, you associate with only mathematics, also other subjects. So generally now I deal with mathematics itself only, but because I need to concentrate on the mathematics. Understood now? That's why. But I know physics, but I don't teach. Right. That is root of a square plus b square. Now step 2. What is the step 2 means? We need to find out angle. That means amplitude or argument we need to find out. Argument means to find out theta, 4 cases will arise. 4 cases means case 1. What is the case 1? If a greater than 0, b greater than 0, both are positive, then theta is equal to tan inverse of mod b by a. Theta is positive. That lies in the first quadrant. Case 2. Here case 2. If, that means it lies in first quadrant Q1. If a less than 0 and b greater than 0, that means second quadrant, then theta is equal to pi minus tan inverse b by a. So now this is also positive. Both angles are positive. In first and second quadrant are positive. Now case 3. If a less than 0, b less than 0, that means this is third quadrant, then theta is equal to negative, you will get it, tan inverse mod b by a minus pi. Now case 4. What is the case 4 means? A greater than 0, b less than 0. That means fourth quadrant. Theta is equal to minus tan inverse mod b by a. This you need to remember. So these are very important. So you have to keep in mind, very important, because this will be very useful for even De Moivre's theorem also. Unless and until you are able to express a plus ib in mod amplitude form or polar form or trigonometric form, De Moivre's theorem can be applied. Understood now? That's why you need to be very careful. Okay, now let us write mod amplitude forms. Shall we discuss now? Let us discuss. Okay. First question. Mod amplitude form of 1 plus I. Mod amplitude form of 1 plus I. See the solution first. So let us say this is Z 1 plus I. First let us find out R. R is equal to mod Z, mod of 1 plus I, root of 1 plus 1, root 2. Next, here actually A comma B, A is 1, B is 1, first quadrant, both are positive. That means theta is equal to, you can write tan inverse of mod B by A. So tan inverse of 1 is 45 degrees, pi by 4. Now therefore Z equals to, we can write R times cos theta plus I sin theta. This is root 2 times cos pi by 4 plus I sin pi by 4. Or we can write this is root 2 cis theta. Answer may be, or Euler's form, root 2 e power cis pi by 4, root 2 e power I pi by 4. Three answers are correct. Right. Shall I give one more question now? Second question. Mod amplitude form of 1 plus root 3i is 1 plus root 3i is Sudha, correct. Okay, now let us say Z is equal to 1 plus root 3i. Here better write down first. A value 1, B value root 3. Both are positive, don't worry. Now R is mod Z, mod of 1 plus root 3i, which is equal to 1 square 1, root 3 square 3, square root 2. Both are positive means theta is equal to tan inverse mod of B by A. That is tan inverse root 3. Tan inverse root 3 is equal to, even inverse trigonometric functions also will do it, 60 degrees. 60 degrees means pi by 3. So now you can write, therefore Z is equal to R times 2 times cos pi by 3 plus I sin pi by 3. Or you can write 2 times cis pi by 3, or Euler formula. 2 times e power I pi by 3. 3 ways you can write the answer. In the options, either this may be there, or this may be, or it may be. Third question. Mod amplitude form of minus root 3 minus I is minus root 3 minus I. Right. Let us solve this one now. Solution. Let us say z equals to minus root 3 minus I. Here a equals to minus root 3, b equals to I coefficient minus 1. Both are negative, means this is third quadrant, Q3. Mod z R value. So mod is root of minus root 3 square 3 plus 1, that will be root 4 2. Now theta is equal to, this is very important, tan inverse mod of b by a minus pi. So tan inverse minus b by a, minus minus cancel, 1 upon root 3 minus pi. This will be 60 degrees, sorry 30 degrees, pi by 6 minus pi, minus 5 pi by 6. So therefore z is equal to 2 times cos of minus 5 pi by 6 plus I sin of minus 5 pi by 6. Let me explain one concept from trigonometry. Cos of minus theta plus cos theta, sin of minus theta minus. Obviously you get like this, 2 times cos 5 pi by 6 minus sin 5 pi by 6. Next, or you can write 2 times cis of minus 5 pi by 6, or you can write this is 2 times e power minus I 5 pi by 6. This you can write it. Okay, I hope everybody will understand. Yes, since these questions are in IPE, but we need to practice speed. This is very important. Speed is accuracy is very important. Okay, right. I hope everybody will understand. All of you understood now? I hope you might have enjoyed this class. Am I correct or not? So if you have any doubts, actually you can chat in the comment section. Okay, thank you one and all. Thank you. Have a nice day. Thank you one and all.